Hey there, it's Jason from Codemanship with another video diary entry. It's been 10 years thereabouts since I hosted a meeting at Bletchley Park called Educating Programmers, where I invited a diverse bunch of very interesting people to talk about this problem of where the next generation of software developers is going to come from. I recorded videos of the presentations of that meeting, which are on our YouTube channel, so I'll post a link to that playlist in the description below. But what I wanted to talk about in this video is, I wanted to reflect on what's happened over the last 10 years, look at some of the things that I think have gone very well, but also to talk about some of the mistakes I think that were made, and hopefully sort of frame some thoughts about where I think we go from here, about how we can improve things going forward. So what was this meeting really about? Well, I can probably illustrate it best with some data. So we take a look at a stat here that I've Googled. The numbers vary, but roughly speaking, there are about 400 to 450,000 software developers and programmers working in the UK, and about 23 million working worldwide. And that number tends to double every 10 years. The demand for skilled software developers rises by about 10% a year as software eats the world. And a whole bunch of people with a whole bunch of different initiatives were trying to essentially produce more software developers faster, because the problem really is it's really hard to find software developers. It's really hard to hire them, and there never seem to be enough of them. And that then becomes a limiting factor on all sorts of things. It's an economic limiting factor as software becomes more central to everything. Well, let's take an example. Our beloved Prime Minister, Boris Johnson, seems quite in favour of vaccine passports here in the UK to allow people to participate, for example, to go to sporting events and bars and restaurants and that kind of thing. Now, behind that, there's going to have to be some kind of software, either new software or a change to some existing software, which means you're going to need someone who can write that software or make that change. So you need software developers, and that's true now of pretty much all government policies, or most government policies. And it's true of most business strategies, that somebody somewhere is going to have to write some code or change some code to execute that strategy, to make that happen. And if it's really hard to find those people and takes a very long time, then that's going to hold your strategy back. And that's something we're seeing across the board now in many walks of life. So it's a big, big limiting factor on your economy. So that's the problem we're trying to address. And a bunch of stuff has happened in the last year to attempt to address that, some of which I think has worked, some of which I don't think has worked. But overall, well, I mean, let's take a look at another stat here. So here's some stats about degree take-up in higher education in the UK. So this doesn't go up to the present day, but it gives us a sort of a flavour here. So veterinary science, massive increase in interest in people becoming vets. I suspect during the pandemic that will have died off a little, because it's quite hard to be a vet over Zoom. But computer science, as we scroll down there, a very modest increase over roughly a decade of 5.7%. So that includes some of the years that these initiatives were taking place. And it does increase year on year. 2020, I think, has been a very good year. I think it's increased by maybe 15%. But I think that, again, might be about the restrictions of the pandemic, that computer science seems like a subject that you could do from home. But on the whole, it's not been spectacular. It's better, but by no means to the levels that we need it to be to address this shortage of software developers. Now, I'm going to start by talking about the positives, things that I think over the last 10 years have gone very well. I think, obviously, the Raspberry Pi has performed beyond probably anyone's wildest dreams. It's a huge, huge success, and not just in education, but in all kinds of walks of life. I think it's one of the most popular prototyping platforms now. If you need you can buy a $5 computer and incorporate into that your prototype. I would imagine there are probably serious products being built around it as well, when you can buy a general purpose computer for that kind of price. And in education as well, we see it everywhere now. So, and not just the Raspberry Pi, there are other products along the same line in the same price bracket that have been hugely successful. So cheap computing has been a big success. And the other thing that's been really successful is code clubs. Code clubs have been very, very popular. And I'm a big fan of code clubs because I think they're coming at the problem from the right angle. So there's some things that have gone very well. A shout out to the Computing at School group. I think they've done some great work, particularly in helping teachers get up to speed, in sort of helping teachers train or retrain to be computer science teachers. So there's some great work going on there, much of it voluntary. So there's a really great community there doing really good stuff. But we haven't really solved the problem. That's the thing. We haven't. There's great stuff has gone on. Lots of things have improved, but we haven't solved the problem. And the reason we haven't solved the problem, I think, is because some fundamental mistakes were made over these last 10 years. So at the risk of being negative, I'm going to talk about these mistakes, but then we'll try and quickly get on to what can we do about it. So mistake number one, let's call it the original sin. And I do feel bad about singling out one person because this is just an illustration. It's not all this one person's fault. And I'm sure she's a very nice person and very good at her job. But let's talk about Year of Code. So in 2014, there was a government-backed, it wasn't a government initiative, but it was a government-backed initiative, a publicity campaign to get people coding, to get kids and adults trying computer programming called Year of Code. And I think they had great goals, and I think they had a lot of really great ideas. And I'm sure they did do some good work. I don't doubt that. But the person they put in charge initially, Lottie Dexter, I feel bad about singling out one person. It's not about you, Lottie. Nothing against you. But when they launched the campaign, she did some TV interviews, and she went on BBC Newsnight and was interviewed by the formidable Jeremy Paxman. And it was a bit of a car crash because it was kind of revealed that as the head of Year of Code, a campaign that was there to encourage us to code because coding is easy, you should try it, it's fun, etc., had never tried it herself and didn't really seem to know a lot about it. Now, it didn't help that neither did Jeremy Paxman, so that was the funny part about that interview. If you get a chance to watch it, please do. You got an interview who has no idea what he's talking about, asking questions of someone who also has no idea what they're talking about. And as publicity, that didn't really help. But it wasn't just Year of Code. There were many other things going on over the last few years. For example, I'm going to mention a BBC television program, which was a great idea to sort of get young people interested in entering technology. Essentially, coming up with an idea for their own product or their own business, and sort of seeing that through to pitch stage, and then they would pitch it, and the pitch that won would get funding or whatever it was, or mentoring. I can't remember what the prize was, but a good thing for a technology founder. Great idea. I really enjoyed the show, but there was one part of it that really, got my back up. So they put together an idea for a product. And then at some point, somebody was going to have to write the code for to prototype this product. And the attitude of the program seemed to be, we'll get someone else to do that. Now, if the problem you're trying to address is there just aren't enough programmers, good ones, you're not going to address that problem by saying, and then we just hire a programmer. Well, from where? Who? You're just kicking the can down the road. And I saw this repeated over and over and over again, not just by Year of Code, not just by the BBC, but in so many places and so many initiatives. That on the one hand, the problem we're trying to address here is the lack of skilled software developers. On the other hand, we'll just get a software developer in to do that. And I think that stems from the fact that the people running these things didn't know what they were talking about. And the people who were advising them didn't know what they were talking about either. But if you don't know what you're talking about, it's hard to find good advice because you don't know one when you see one. So the original sin, putting people in charge, not just in things like Year of Code, but in government, in education, and so many other places, putting people in charge who didn't know what they were talking about. Um, mistake number two was basically they had the wrong goals. And that's an illustration of that program, where if the goal here is to address the shortage of software developers, that's the thing that's holding all these businesses back. We don't necessarily need more tech businesses. We need more software developers to work for tech businesses so that they can be tech. So there can be tech. It can happen. But we also saw it, for example, in the way that computing has been addressed in schools. They're not trying to produce software developers. They're trying to fill computer science courses. Not the same thing. Again, because the wrong people were in charge and were getting advice on the whole from the wrong people, unknowingly, I'm sure. They didn't realize that there was a difference between software development, computer science, and computer programming, that they're related, obviously, but they're not the same thing. So they were working towards the wrong goals, really, trying to solve the wrong problem. The problem is not there aren't enough people studying computer science, because computer science degrees, on the whole, I can do some shout outs to ones that are different, like University of Sheffield, for example, a great example. But computer science degrees, on the whole, do not train you to be software developers. That happens afterwards. So they don't produce software developers, basically. So we were trying to address the wrong problems here. Mistake number three was the way they went about it, particularly in schools. So computing in schools had kind of been watered down into this subject called Information and Communication Technology, ICT. What we would have once called it IT. And by the time these initiatives were firing up, basically kids were not learning programming and computer science. They were learning about spreadsheets and Word documents and web pages and online safety and stuff like that. Now, this is stuff that people do need to know. So I think there's another mistake they made alongside this one. But the mistake they made was to completely replace ICT with computer science as an academic subject from a very early age. Now, I went to a school that has a really strong reputation for music. An excellent music department, and they produce many world-class musicians over the centuries, in fact, because it's a very old school. And I had music lessons at school. We had weekly music lessons, and I hated them. And they really turned me off music, trying to learn about music theory and listening to Mozart and stuff like that. And so I was not switched onto music at all by my music education. But I did eventually sort of seek out the guitar myself. It was under my own steam that I started learning guitar, because I wanted to do it because it seemed interesting and fun and challenging and creative. And that's how my computing career started. It didn't start with lessons in computer science. It started with a home computer and me wanting to know how it worked and trying to write my own games and little programs and stuff like that. And then approaching it as a fun, creative thing, which is why I think code clubs have been so successful compared to computing at schools. Not to say that computing at schools has been a complete failure, but I'm talking about the level of success that we needed, the level of uptake that we really need. And I think that's because they came into it from the wrong angle. They approached it as a fairly dry academic subject, whereas I think to begin with, certainly it should be fun and creative, and maybe not taught as a subject at all, but sort of absorbed into other subjects like art and design and science, so that people can see how computing can apply to the kind of things they want to do. In the same way that I learned to program to write games, I didn't write games to learn how to program. So I think coming at it from the wrong angle has been a fundamental error, a fundamental mistake. And the other mistake was to replace, not to have computer science sit alongside those general computing skills, those general digital skills, but to completely replace it with this dry academic subject. So now those kids who are not going on to do GCSE and A-level computing are leaving without those general computing skills that employers also really need, but also we need them. Everybody needs to, I've got people I know who didn't touch a computer until a few years ago, who realized that they were not going to be able to get on in life, just general life, without learning how to use a computer. So I think that was a big mistake and again, to conflate them, that they're the same, they're kind of the same thing. No, they're not at all. It's not one or the other. You kind of need both. So I think that was a mistake. They came at it from the wrong angle. I think maybe they listened, but again, I think this is because it was the wrong goal. They were setting out to fill places on computer science degrees. So naturally, that was the route that they took, which is understandable. But again, that's about getting advice from the wrong people. If they'd asked software developers, I think the advice would have been very different. We probably would have pointed them towards the code clubs. Like my computing club at school, it wasn't on the curriculum. We didn't learn it as a subject, but there were computers, and many of us had them at home as well. And it was just a fun, creative thing. And we naturally seek out the theory in the same way that as a guitar player, I've naturally sought out some music theory, just enough to do the things that I want to do. To achieve my ambitions as a computer programmer, I've had to learn some computer science. And I think that's naturally how it happens. And finally, and I think this is probably the biggest mistake of them all, and again, it stems from that original sin of the wrong people being in charge, people who didn't understand the problem. They've so grossly underestimated the size of the problem by orders of magnitude. We're talking multiple zeros after the numbers, and by orders of magnitude. And one perfect illustration of that is how, when they were originally putting the budget together, the government budget, to retrain teachers to teach computer science, I think the budget per teacher worked out at the price of an Egg McMuffin. To teach someone to teach computer science, including computer programming, for the price of an Egg McMuffin. Now, thank God for groups like Computing at School and other groups who've appeared, connected groups who've appeared since then, who've taken on this challenge, mostly voluntarily, I think, to help teachers with that. So it's not, thanks to the goodwill and the expertise of people who did know what they were talking about, they've been able to address this problem to a larger extent. But initially, the government's Maggie Philbin, who's a well-known TV presenter here, a media personality. She used to be on a program called Tomorrow's World. She runs this fantastic thing called Teen Tech. I'll post a link to that in the description below as well. Teen Tech is an annual competition run by Maggie and her colleagues that essentially challenges teenagers at school, with the help of their school usually, I think, to create innovative new technology. And year on year, as this competition has been running, the standard gets higher and higher and higher. And the ideas are fantastic, but not just the ideas, but the realization of those ideas, the prototypes that they build, the real stuff, real technology, real software, etc., etc. And they do it themselves. And Maggie was asked to write a report for the government about digital Britain, digital skills in Britain, on our digital future. And she rightly identified that you need to add a couple of zeros to your budget. Now, I disagree. I think they need to add 3 zeros to their budget. She correctly identified that they grossly underestimated the level of investment that was required. And that's because they grossly underestimate the true size of the problem. As software becomes more and more central to everything, to every walk of life, your ability to find software developers who can create or change that software becomes a limiting factor on everything, on your entire economy. And I don't think they've quite got that message yet, that it's not even a multi-billion pound a year problem. It's a multi-trillion pound a year problem if you look at the world as a whole. And one great example of that is that the software that the government have attempted to build or to adapt during the pandemic, it's been an absolute disaster. You have to be able to find good software developers. And here's where I think it's not worked over the last 10 years. It is no easier today, probably even harder today, to hire good software developers than it was 10 years ago. So whatever we've been doing, and some great stuff has been done. There's some stuff out there that might not have existed that's very laudable, like Teen Tech, like the code clubs, like Computing at School, like the Raspberry Pi. There's a lot of really great stuff that's happened, a lot of very inspiring stuff that happened over the last 10 years that I, really impressed by. But ultimately, we have not solved the problem. If the problem is where are the software developers going to come from, we've not solved it. So that's enough moaning and complaining, and my apologies to Lottie. I didn't want to single her out, but I needed an illustration. So, you served as an illustration, but there were many instances of initiatives and programs and organisations where the wrong people were put in charge. Our government is very good at that, putting the wrong people in charge, and everything else kind of flowed from there. Not their fault. They didn't know they were the wrong people because they were the wrong people. So here's where I think we could make a difference. We need to address these problems one by one. Number one, let's fix that original sin. Let's put the right people in charge. And who are the right people? Software developers, not employers, not academics, although we will need their help. Certainly not the government, please. Actual software developers. That whatever we do going forward to address this problem of creating new software developers, it should be done by, the agenda should at least be set by the industry itself, not the people, not the paymasters, but the people actually doing the work need to be driving this. So that's thing number one that could be fixed. So one thing I'm going to be doing over the next year and beyond is trying to build a community around mentoring with the kind of long-term, and we're building a community of software developers who can begin to set the agenda on this. Number two, how do we fix problem number two? Well, I think, what was problem number two? Wrong people, wrong goal, that was it. I should have written this down, really. That's so professional. This is why I don't work in television. Yeah, the wrong goals. The goal is not to fill computer science degrees. Computer science degrees, obviously, computer science is important in the same way that physics is important to so many disciplines. Computer science is very important. We do want more people studying computer science, but that's not the problem we're trying to solve here. The problem we're trying to solve is the lack of software developers. So I think we need to go back and take another look at proper long-term, maybe degree level, maybe ending in a degree, long-term paid software developer apprenticeships. And again, I think that needs to be not driven by employers, not driven by academics or by the government, although we might need their help. I think this is software developer apprenticeships, apprenticed to who? To software developers. So I think we need to take another look at that. And I think this community that I'm hoping we can build can do that. So mistake number three, I think there needs to be a big rethink about the way that it's taught, especially for younger children. I think it needs to be, I think we need to go back to code clubs at school, and also absorbing computing into other subjects and approaching it as fun, creative and challenging. And then those kids that display an aptitude and who enjoy it can then go on and seek the theory, and then hopefully the schools will be tooled up for that in terms of qualifications and teaching, which they pretty much are these days. So I think from age 5 onwards, computing should be fun. So we're talking about making cool stuff, whether it's music or art or wearable stuff or whatever. Let's go back to that and let's leave the theory for a while. Those who are interested will seek it out. And then finally, time and money, resources. This is the big one. This is the barrier that I hit as a trainer, as a coach, every day with so many organizations. There never seems to be the time or the money. Apprenticeships particularly have suffered from this. That a lot of employers have taken on software developer apprentices and then kind of left them to their own devices. So they're doing the theory, they're going to college and doing their courses or going on training courses, but then day to day, when they're supposed to be learning from more experienced developers, those experienced developers are considered too valuable to give up for that low value work, which is a terrible, terrible mistake. Especially when you get to my age, I think it's probably the most valuable thing we can be doing is mentoring other developers as they come through. But so many employers are not willing to make that investment, to give up those people's time, because they're the ones who are getting things done. So you need to scale back the getting things done part. So I generally advise employers, expect to spend about 20%, 25% of everything you spend in software development will be on something like this. It's a big chunk. And a lot of them balk at the idea of spending that kind of money just on mentoring developers. So it often comes down to time and money, but it's only a problem if you continue to underestimate the size of the problem. The reason why it looks too expensive is because people have grossly underestimated how much this is actually costing us because we're not doing it, how much it's holding our economies and our society back. So my thought on that is, well, we need to get that message across. Not how much does it cost, but how big is this problem really? So I'm hoping I can persuade some universities and some researchers to do some work on this so we can get a more sort of definitive answer on what is the impact of being unable to find software developers on businesses and on the economy and on the government and on life in general. What impact is this having? My instinct is it's massive, it's huge. And as we go on year after year and as more and more gets done with software, it's just going to get bigger and bigger and bigger. This is the technical debt that society is building up now around this question. And then hopefully when they see the size of the problem, the cost of the solution might not seem so vast to them. Orders of magnitude less to solve this problem. So there you go, educating programmers. I'm really glad I did it. I'm hoping in the next year or so, if the pandemic allows, if the virus will let us, to follow this up and to host another one. I would love to do it at Bletchley Park if they can take events. So we can revisit this and have this conversation again. But I'm very keen now to start trying to build a community within software development of people who are like-minded about this, who are interested in this, to see if we can't maybe start driving this ourselves. Because for all the good things that have happened, the one thing we set out to do, we haven't. And so we need to take another pass at this. We need to give it another go. But maybe this time try and avoid some of the mistakes that were made. So there you go. That was Educating Programmers. I highly recommend watching the videos. Also, take a look at Teen Tech. It's fantastic. Take a look at some of the inventions these kids are coming up with. They're amazing. I think that's the way forward for this, to get people interested not in technology for its own sake, but in what they can do with the technology. I think that's going to be the big thing. And they will naturally seek out the skills and the theory that they need to achieve that. Okay, well, there you go. I'm going to try and record another video diary next week. But until then, stay safe and enjoy your Easter if you celebrate that.